Hello everyone, welcome back to my channel, which is Certified Business Analysis Professional. My name is Varun, and I hope you are finding my YouTube tutorials helpful for your CBAP, ECBA, and CCBA examination. So far, so good. We were continuing with the techniques, and today we will continue with these three techniques, which is data mining, estimation, and the functional decompositions. And from the examination point of view, uh, functional decomposition is a very important technique and the estimation as well. So let's continue. First is the data mining. So what is data mining? Data mining is used to improve decision making by finding useful patterns and insights from the data. If some of you working with the analytics tools like the Power BI, Tableau, ClickSense, Google Analytics, if any of you are familiar with these tools, you might be familiar and you might relate these things, right? So data mining, whatever the analytics tools are doing, they are just doing the data mining and implementing some sort of algorithms to find the patterns and to predict the future. So if you people are familiar, then it's good. Otherwise, for the layman, it's a kind of lot of data you are playing with, and then you are trying to categorize those data. You're trying to identify the similarities in the patterns, trying to do some trend analysis, right? You're trying to match the troughs and the uh, uh, curves of the graph of the data to find some similarities, right? So data mining is used to improve decision making by finding useful patterns and insights from data. Data mining is an analytic process that examines large amounts of data from different perspectives and summarizes the data in such a way that useful patterns and the relationships are discovered. Data mining can be utilized in either supervised or unsupervised investigations. So supervised or unsupervised, I think I have also covered these topics in past, so you can go through those videos. Data mining is in general term that covers descriptive, diagnostic, and predictive techniques. So in order to understand these descriptive, diagnostic, and predictive, let's take an example. Uh, for an example, there is a e-commerce site from which deals in clothes and apparels, and during the October, November, and December, the sales is very high for the woolen clothes or jackets or caps, right? So that's a data that we found. Then if you try to analyze, then the description would come that during the winters, because that time it's a cold, very cold outside, and people used to wear those woolen clothes, right? So that's a description. Due to winters or the cold weather, people generally wear the clothes. That's why they purchase those. That's a description. Then when you go into diagnostic way, then you try to do more diagnostic, like try to understand why something happened. So if the sales are high, then the diagnostic way says this is too much winter or too much cold outside. That's a diagnostic way of understanding. Then when you have a past data, let's say for 2 3 years, you try to come to a conclusion like the next year during the same period, from October, November, December, again the sales will be on peak, because that's a prediction based on the data that you have analyzed. So description is simply describe what happened in the past, presenting data in a summarized format, like the sales uh, was on a peak. Then diagnostics say why it happens, because of the winter or because of the seasoned or seasonal thing, or some events happen like a Black Friday sales is very high. So diagnostic is like the Black Friday is there, that's why the sales is high. Predictive is based on the data that you have collected. You are trying to predict the future, like the next time during the same time, like during December, mid-December, or mid-June, or midsummer season, or Black Friday time, or Diwali time, or Christmas time, the sales would again be high. That's a prediction. So I hope you understand descriptive, diagnostic, and the predictive. Now, what are the elements in the data mining? It's requirements elicitation. Obviously, whatever the requirement that we are eliciting depends on that. You try to analyze. Data preparation. For the data preparation, we try to analyze the data sets, right? So we try to find out like on what data for to understand the sales, right? Then we have to see like offline, how much offline is being sold, how many online sales are being there from the retailers, from the distributors. So we, you know, col collate all those parameters, all those from different aspects, and then we calculate it. Data analysis, obviously, we try to analyze the data on that, and then for doing this analysis, we try to implement the modeling techniques. So here, the modeling techniques like classification and the regression tree, also acronym as CART, C5, and other decision tree analysis technique. So the term CART is merely a modern umbrella name for the decision tree algorithm. So the decision tree algorithm itself is known as the CART, classification and the regression trees. For the decision tree, and I will put a link on top somewhere here. You can find the link and go through, understand the decision modeling or decision tree in detail. For cart analysis, I'll give you one example in the next slide. But before that, let's finish this up. Linear and the logistic regression. In linear and the, first of all, regression is something when there are some variables. One is independent variable and another is the dependent variable. So if we trying to measure something, then there are two variables that this resultant would be dependent on. In order to understand it, like will there be a rainfall today? So weather forecast we are talking about. So weather forecast would be dependent upon the how the climate is outside, which season of the year is this, how much the wind is blowing through. So there are different parameters that it's dependent on, right? So that's how you come up with the forecast, or whether the mist in the air or not, right? So there are different parameters that it depends on. Then the neural network, it's a kind of intelligence, artificial intelligence or modeling languages we are using. So this is nothing, this is not of much uses for us. I'm expecting very less question from this. Then the predictive scorecards. This is another way like how we try to analyze the data in some scorecard format. And then final, the deployment of whatever the analytics techniques or modeling techniques we try to implement those based on the requirement elicited. Let's move and we'll talk about classification and the regression tree, which is acronym as CART. And this is again the umbrella form of the decision tree. So you can see root node or parent node on top. Then these are the internal nodes, from also known as the decision nodes, you can say, from where the separation is being done, divided into two parts. Then again the decision node comes here, internal node, then it divided into internal node 1 and the leaf node. So this is a classification and the regression tree, which is also acronym as CART. And here you can see the splitting is being done, and these are the subtrees. Then the important thing that we were talking about, linear and the logistic regression. So what is the difference between linear and the logistic regression? So in a diagram below, you can see here, uh, when we are saying linear, linear is there are number of values that could come. If we say weather forecast, then there are dependent and independent variables on that, right? So as I said, like the wind, how much wind is blowing, how much mist in the air, how what is the current season of the year, right? And which place you are right now, it's a hilly area or plain. So different parameters, variables are there, which make the alter in the resultant. It will decide whether the rainfall will be heavy, low, or mid, or not at all. So these are dependents, right? So dependent variables and the independent variables, and their values can lie between 0, 0.1, 2, 3, 4, right? So it could be having any value dependence on the independent and the dependent variables. That's a linear regression. And linear, why we are saying? Because there would be a path that would be a kind of a line and having variables, different values altogether. Whereas in a logistic regression, there would be a simple S curve and the value would be between, not between, but kind of a binary value, 0 or 1, would be a Boolean value that could be true or false. Right. So for an example, when you go for a corona test, either that would be negative or positive, right? And there would be no other mid value, right? So either that would be positive or negative. Will there be a rainfall today? Either it would be yes or no. Again, whether you will pass, yes or no. So in similar way, there would be a binary value 0 or 1. If we used to denote true as 1, then it would be 1, and false as 0, then it would be 0. Right? So it would be a logistic regression. So I hope you understand linear and the logistic regression difference between those two. Let's move ahead. Then the pros and the cons. So pros: reveal hidden patterns and create useful insight during analysis. So those who are working with the analytics tool, they can relate it. But those who are not familiar, I would recommend them at least they should go through some of the Google Analytic explanation or YouTube tutorials. Any of the analytics tool, you would able to understand like what does this analysis and insights and data mining, also all sort of things. Reveal hidden patterns and create useful insights during analysis, helping determine what data might be useful to capture or how many people might be impacted by specific suggestions. Can be integrated into system design to increase the accuracy of the data. Can be used to eliminate or reduce human bias by using the data to determine the facts. Applying some techniques without an understanding of how they work can result in erroneous correlation and misapplied insights. Access to big data and to sophisticated data mining tool sets and software may lead to accidental misuse. Many techniques and tools require specialist knowledge to work with. All those points are very relevant, and might be you are understanding those. But those who are familiar with this and they see like I'm taking too much time on this topic, uh, then please bear with me. There are people from different background, from manufacturing or some other domain, who might be having difficulty to understand this. Let's move to the second technique, which is estimation. Estimation is used by the business analyst and other stakeholders to forecast the cost and effort involved in pursuing a course of action. So estimation is simply that you are calculating based on different parameters, you are trying to arrive on one decision or one result. That, for an example, the cost of the product. Then you are, trying to estimate the cost of product. Different factors would be there, dependent on the raw material, dependent on the service charges, dependent on the VAT and the GST, whatever the government taxes been involved. uh, and then the bill of material, right? The efforts been taken, the logistic. So different parameters, and then you come with the estimation that the product cost will be this much. So here the estimation is used to support decision making by predicting attributes such as cost and effort to pursue a course of action, expected solution benefits, project cost, business performance, potential value anticipated from a solution, cost of creating a solution, cost of operating a solution, potential risk impacts. So the points that I have considered, those were related to the cost of creating a solution. Apart from this, there were some project costs that I try to cover, and then different like expected solution benefit. If you are creating a product that is a multi-purpose product, then obviously the benefits are high, right? So it then the price might change based on that. In a first way, you might be saying, oh, this product might not have that cost, but when you go through the benefit of that product, then you might come up with a different prices, right? For an example, if I would say for an example if I would say that um, a plier, like a plier you are purchasing, that plier is used for multiple purposes, like for it could be act like a hammer, it could be used to you know grab something tightly, it can be used for some other purpose. So the benefits are high, so accordingly the prices might inflate. Business performance, potential value anticipated from a solution, cost of creating a solution, cost of operating a solution, cost of operating. So does that need any for that plier? I would say you can handle it by your own naked hands. Nothing specialized skill set you need, right? So that's a very fair example. So there is no cost associated at all for operating that. So in a bigger framework, if you understand like a solution, you're creating an application altogether, you're creating a big machine altogether that having a different operating ways, processes. So these things you have to understand. Potential risk impact, that's another factor. Now, how we try to estimate, though there are different methods of estimation. We'll talk about focus more on rough order of magnitude and the PERT because these I think are important from the examination point of view. But from overall perspective, let's try to understand what is top down. Top down is something high level you are trying to estimate. For an example, this is a bottle, right? This is a plastic bottle. So you can estimate on like, okay, this is a plastic bottle that could be cost around 100 rupees or $10 or something, right? But when you go through the quality of material, the transparent and the benefit or the cap or so different aspect, then you might come up with different prices. Then it's like top down, that you consider the top stuff and then you derive the price. Bottom up is in a similar way. Now if I say bottom up is like, okay, this bottle is of a plastic, the cap is having a proper you know a washer inside that would tightly close this bottle. Then this bottle is very light, you can carry this bottle, and this is non-breakable plastic or non-breakable substance. So what you are doing is you are going to the leaf node and trying to arrive on the estimate. You are trying to estimate the price. So that's a bottom up approach. Then parametric estimation, and the another example that I have given, the parameters. You try to estimate based on the different parameters, right? So let's say this is a marker. This marker inside that having a permanent ink, so that's one parameter. The ink is of a red color, that's a second parameter. This body is made up of a plastic, and which is properly, easy to hold, which is very light. That's the third parameter. Fourth parameter, you can tie this in, having this, you can tie it in your shirt. That's the fifth parameter. So different parameters you are using to calculate or estimate the price. That's just a layman language. You can as a analogy you can relate different things. uh, then rough order of magnitude. What is rough order of magnitude? This is important, where this can be between 50% to minus 50%, plus 50% to minus 50%. We'll talk about rough order of magnitude later cases, but high level, try to understand where there you cannot estimate. Then you apply a method which is rough order of magnitude, and that is between 50 plus, 50% plus, and 50% minus. Rolling wave, that's another method. So as and when more information is available, you try to estimate, and it is during a project progress. When in a progress, like when you go through the iterative approaches, when there is no requirement upright upfront available all information, that's why you try to implement the iterative way of development, right? As and when more information is available, you can change the priorities, you can adjust the backlog, you can implement or remove some stuffs from that. So that's comes in a rolling wave. Delphi, or somebody say Delphi, using opinions from a group of experts to reach to a consensus. Right? You're taking inputs from expert who are having expertise in that estimation or calculation of that stuff. For an example, if we are talking about price of a soap, right? New brand, new soap has been created. Then to arrive on the estimation, you those who are already in a soap industry, they can help you in understanding what would be the price of this based on different parameters, different tricks, different estimates, right? So they dependent on experts. Then finally we have PERT, which is also known as Program Evaluation Review Technique. Those who are already done with the PMP examination, they are familiar with this PERT, Program Evaluation Review Technique. We'll talk about the expected time, which is important for the examination, how to calculate the expected time, and critical path method. That's not important, but you must understand what is this. We'll come to that in a next slide, but let's go through what next is accuracy of estimation. The accuracy of an estimate is a measure of uncertainty that evaluates how close an estimate is to the actual value measured later. It can be calculated as a ratio of the width of the confidence interval to its mean value and then expressed as a percentage. In order to understand this, how accuracy of estimate. So if we say, okay, can you estimate the price of this marker, right? You would say, uh, and the price is hidden. Let's say the price is hidden somewhere here, and we say, okay, let's you can guess the price. If you say, okay, this is of $10, uh, then we would say, okay, how much rough order of magnitude, based on a rough order of magnitude, how much you will cost this. The the correct price is $10, but you would say that it could be between 15 or 5, right? So that's almost 50%. You said 50% rough order of magnitude. This means the uncertainty is very high, the confidence is very low, right? If the rough order of a magnitude is high, like 90% you are saying, then this means the confidence level is high. So when the confidence interval is very high, you are closer to the correct estimation. We'll take an example in next slide, but high level you try to understand confidence interval or the rough order of a magnitude. If the uncertainty is high, then rough order of magnitude technique we use, and here a very little information is available to arrive on a estimates. Okay, Now the source of information. Source of information. Uh, so analogous situations using an element. It could be a project, initiative, or any risk. That would be a source of information for estimation. Then organization can use their organization history where they are estimating price of any product based on different parameters. They can go through the history, what how they have arrived on that price earlier. Or you can take a expert judgment, help of some expert to arrive or derive any price. Then decision and reliability of estimates. So we'll continue with the rough order of magnitude again here. For an example, if a team estimated that some task would take 40 hours, right? A team said like to complete the task, it would take 40 hours. In 90% confidence interval is there. 90% confidence interval. So 90% of 40 is 36. 90% of 40 is 36. Then you have to calculate, okay, how much hours it is, uh, deviation of hours from the actual hours. So it is 4, right? So what you do, 4 you subtract, which is 36, and you try to add 4 on the actual hours, then it is 44. So 36 and the between 36 and the 44s, if the 90% of confidence interval is there, right? So you are very close to the actual estimate, which is 40 hours. Only 4 hours difference is there, right? Plus 4 and minus 4, which is 90% of confidence interval, depending on what they gave as an individual estimates. Now come with another example. If we say 95% of 40 hours, right? The confidence interval is getting very closer. High confidence interval is there, right? Which comes as 38 to 42 hours. So 95% of 40 is 2. Sorry. So 95% of 40 is 38, right? So how much variation or from the actual 40 hours, it's 2. So what you do, you try to subtract 2, which is 38, and try to add 2, which is 42. So now the confidence interval, as the confidence interval is higher, let's say 97, 98, then you are very close to the estimate, right? So higher the confidence level, narrower the range would be, right? In the first case, if it's 90%, the range is little, very, uh, uh, it's wide range, right? 36 to 44. As a confidence interval increases from 90 to 95, then the range would get narrower, which is difference of 2 only, plus 2 and minus 2. So I hope you understand. The confidence interval is high, then this means you are very close to the estimate. Now, what are the contributors to estimates? So it could be different elements you are considering, the teams you are talking to, you are taking opinion of the experts, and you are reviewing all those. So these are the contributors to estimates. So why I have taken these different topics based on the elements I have taken you through. Otherwise, I would have an option like whatever example I have given you, I would have given it in a first slide. But so that the sequence would be maintained, the elements in a continuous fashion, and you understand those. I hope you understand. If you didn't understand, still didn't understand, please feel free to call me or give me a ping or put it in a comment. Now, as I said, let's talk about the PERT, which is Program Evaluation Review Technique. Here, the important thing is the expected time. What would be the expected time? So the expected time, the formula of the expected time is optimistic time plus 4 times the most likely time plus the pessimistic time divided by the 6. In a question, you would be getting optimistic time, most likely time, pessimistic time. All those you would be getting. And then you have to simply apply the formula and calculate the expected time. Very simple. Then the critical path method, this is a part of the PMP, not for you, but just try to understand. The critical path method is the path or the maximum duration. The activities that are taking the maximum duration would be considered as a critical path. You can see here it is taking 2 weeks, 3 weeks. So you started here. The first activity took 2 weeks. The second activity took 3 weeks, right? And in order to go to this step, you are taking 2 weeks. So the overall number of weeks are 2, 3, 5, and 2, 7. It's taking 7 weeks here. But in a other way, if you see this, if you go by this way, 2 weeks, 3 weeks, 6 weeks, 8 weeks, 9 weeks. So this is the critical path which is taking the maximum time. So if critical path is something that you cannot finish this project before this time, this is the this is the maximum time that you need to take in order to complete this, all the activities or the project, right? So that's a critical path method. So what are the pros? Estimates provide a rationale for an assigned budget, time and size. Without an estimate, teams making a change may be provided an unrealistic budget or schedule for their work. Having a small team of knowledgeable individuals provide an estimate by following a defined techniques generally result in a closer predictor or of the actual value than if an estimate was made by one individual. And this is true, right? Cons. Estimates are only as accurate as the level of knowledge about the elements being estimated without organizational or local knowledge. Estimate can vary widely from the actual values determined later. Using just one estimation method may lead stakeholders to have unrealistic expectation, obviously. So you must go through the different estimation method to arrive on a relevant estimate and compare like what estimates are. And as I said, like the PERT, in a PERT, when we calculate the estimated time, where the optimistic time most likely and the pessimistic time is being uh, used to calculate the expected time, then it comes a more realistic. So the sample size is big, more data is available, you can implement the methods or the techniques easily on the sort of data, and then you can arrive on a uh, more realistic picture. Then the final, functional decomposition. So as a keyword uh, saying functional decomposition, here you break down the functions into smaller chunks that would help or reduce the complexity, that would help you to calculate or estimate something very easily. So functional decomposition helps manage complexity and reduce uncertainty by breaking down processes, systems, functional areas, or deliverables into their simpler constituent parts and allowing each part to be analyzed independently. Functional decomposition approaches the analysis of complex systems and concepts by considering them as a set of collaborating or related functions. The depth of decomposition may vary depending on the nature of components and the objectives. Functional decomposition assumes that subcomponents can and do completely describe their parent components. So for an example, here the first picture is shown, which is a functional decomposition of a car. So automobile, uh, and it's a powertrain, chassis, body, electrical, climate control. So these are different aspect of a car is broken into, and then we have considered the chassis, and then we further break down into frame structure, suspension, steering, brakes, wheels, tires, control system. So it could be a third level as well, where you are taking out the brakes and then try to divide it into different aspects. That's from manufacturing or automobile industry. So people who are from manufacturing industry, they would be able to relate it with functional decomposition. And those from the IT background, you can take example of a Zira where you are logging the requirements, right? So it could be the initiative has been selected. From that initiative, you come up with a program epics, right? That's a program epic 1, program epic 2, program epic 3. From that program epic, you comes down to the stories, story 1, story 2, story 3. In one story, there are 3 different tasks that you have created and then subtasks. So this is a decomposition, how we do that. So that's very easy, and you can expect one or more question from functional decomposition. So what are the elements? So decomposition objectives. So what are the objectives of the decomposition? It's basically used for easing up things for the estimation and the calculation. So measuring and managing, designing, analyzing, estimating and forecasting, reusing, optimization, substitution and encapsulation. These are the different objectives for the decomposition. Subject of decomposition, it could be business outcome, work to be done, business process, functions, business units, solution components, activity, product and services, decisions. So these are, different. You can apply this decomposition on different subjects or the domains. Then level of the decomposition, as in the previous slide where I said for the automobile or car, we done first level of decomposition, then we consider chases and break down it further. Then it could be a third level of decomposition as well, where we say, okay, brakes, there's a hydraulic brakes or the normal brakes, right? Then representation of decomposition results, how we are representing those decomposition results. It could be in a tree or diagram form. It could be in nested diagrams. It could be kind of a use case diagrams, state transition diagrams, cause effect diagrams, and I hope cause effect diagrams, which is also known as Ishikawa diagram, fishbone diagram, right? Decision tree, mind maps, component diagrams, decision models and notations. So you can represent that decomposition result into different uh, techniques or diagram or representation form. So these are below. What are the pros and the cons? The pros are makes complex things easy by breaking down problems into feasible parts, provides a structured approach to building a shared understanding of complex matters among a diverse group of stakeholders. It simplifies measurement and estimation of the amount of work involved in pursuing a course of action. Then the cons. Missing or incorrect information at the time decomposition is performed may later cause a need to revise the results. Many systems cannot be fully represented by simple hierarchical relationships between the components. Every complex subject allows multiple alternative decompositions. Performing functional decompositions may involve deep knowledge of the subject and extensive collaboration with the diverse stakeholders. So these are as to as these things I have taken out of a book, so you can understand those. So this is it from today's session. We'll continue with the rest of the techniques. So far, if you are finding my YouTube tutorials helpful, please at least give me one like so that I can say, okay, you are finding this content useful. We'll see you soon in a next session. Till then, take care and goodbye.